we got a few folks whose grades are starting to slip a little bit. Some of it's due to not turning things in. Some of it's people are struggling now in the last couple of weeks. The parabolas and ellipses, so it looks like it may have tripped a few people up or didn't do as well in the test as they wanted. But overall, class is still looking pretty solid. But we have had just a few people slip those 70, which most this year, you guys have your grades above 70%. So if you need to go back and redo something, or if you got some missing stuff, look at getting that turned in soon. So keep your grades up there. But anyway, hope you had a great weekend. It was nice weather this weekend. Little chilly at times, but a lot of bright, sunshiny times out there. For the rain that's coming in now, we're supposed to have possibly severe weather tomorrow. But I hope you enjoyed it. Myself didn't make it to a movie because we got too busy with other stuff. Wanted to go to a movie this weekend. My wife wanted to go really bad, but we went and picked up a dining room table and chairs from my sister this weekend. So that required leaving Saturday morning at 7:45 in the morning, and we got home at midnight because her house is in western Oklahoma. And when you're a pickup pulling a trailer, that's about a 5.5, 6 hour trip one way. And so we went Saturday morning, came home Saturday night, got home at midnight. Then Sunday we get family to help us unload the table and chairs from our trailer and get it in the house. But it's done. But my sister now lives in Louisiana. The house they're selling the house in Oklahoma. So and they were going to give away the dining room table. It was like, hello? No, they said, please take it. So it's her husband's a doctor, so it's a nice table. The table's 12 feet long and has 12 chairs. It's a replica of the Vanderbilt's table they have at the Biltmore Estates in North Carolina. It's a replica table. And if you've never seen the Biltmore Estates, here, let me show you a picture of the table that's at the Biltmore Estates. There's the table at the Biltmore Estates at the Vanderbilts. And that thing is huge. Ours is not nearly that big. The replica table is 12 feet long and about 3.5 feet wide. This one, I don't know how long it is. It looks like it'd be probably 8 feet wide. But our chairs are similar to that. Not exactly like that, but they're very similar to that on this replica table. But we have 12 chairs instead of there's like 26 around that table. That's a lot of chairs. But anyway, so we have this really nice dining room table now with 12 chairs to fill that great big room we added on. And it just barely fits, really, without getting into the living room side of the room. That's a huge table. But since my sister was giving it to us, we rented a trailer and drove to Oklahoma just because it was worth it. And my wife loves it. So it's worth it right there. Just make my wife happy. You know how. There you go, guys. Good tip. Make your wives happy. Your life gets real easy. And she's very happy with it. So, all right. It's 9 o'clock. We've given folks a few extra minutes to find their way to class. And if they haven't found their way yet, then I have no hope for them. Just kidding. Some of them make it in. We're just missing 3 folks right now. All right. Let's take a look at our Algebra 3 class. Let's go to the grade screen as usual. Again, that's the best place to start your day is on the grade screen above so you can make sure everything is turned in. Was there a submitted date? Do I have a grade? Am I happy with my grade? Do I need to go back and redo anything? Here's my overall semester grade here at the top. Where are we at? These 2 assignments were due yesterday. The parabolas and ellipses assignments. That was due last night. So March 9th, we have 2 assignments. 6.03A and B, hyperbolas and a collage. Oh, we got to do a collage. Remember, did you ever do those in grade school where you got a poster board, you got some magazines, you cut out pictures, you made a collage? Okay, we're kind of doing something like that. We're just not going to do it with magazines and a poster board. Unless you want to. You can do it that way and take a picture. But no, we're going to look at it. But yes, look at hyperbolas today. 603. All right, we are right here, hyperbolas lesson and the constant. And then next week we get the test. So we just spent a couple of weeks on this unit right here. Last week we did those lessons. This week we're doing these lessons, and next week we're taking the exam. So we're going to wrap up this conics pretty quickly. And then we'll get into matrices, which are a lot easy, really, pretty easy and fun. So hyperbola 603A. Oh, well, I didn't want the assignment. I wanted the lesson. There we go. Lesson. All right. As you recall, in an ellipse, right? Ellipse is like an egg shape, right? Kind of like a circle that's been stretched out a little bit, something like that. The set of all points, x, y, is the sum of the distances that are two fixed points, the foci. And we had that last week where we had the foci inside. There's two of them, and the distance between them both work the same. For hyperbola, it is the difference of those distances that is fixed. So, oh, I should have pulled this up. I didn't do it. Algebra. Oh, there's what I want. Tim Brzezinski or whatever his name is. Okay, so with a hyperbola. See, the hyperbola is like back-to-back parabolas somewhat. See, it's kind of like these black curved lines kind of look like parabolas that are back-to-back. And there is a vertex for each side of the hyperbola. And if you draw a straight line between those, that's called the transverse axis. And there are two focal points with a hyperbola, just like there was two focal points last week for an ellipse, but it was inside the ellipse. Remember, we had the big ellipse here with the two focal points inside. This time, the two focal points are inside the two halves of the hyperbola. Just like the focal point was inside when we had a parabola, it's inside. And all the points on the hyperbola, either side, have a special relationship. And then you notice there's a difference. The green line is the length from this point to focus 1, and the red line is for focus 2. And if we compare those, I'm going to take the transverse up. If I take the green line and subtract the red one, it equals the distance between the vertex, the two vertices. See how that works? The longer line subtracting the shorter line will give you the length between the two vertices, the transverse axis. And that will be true regardless of where that point is. If I bring the point down here to the vertex, all right, there's the longer line, there's the shorter line, and it's equal to the axis, which tells you that the focal points are the same distance away from the vertex on each side. Right. All right, let's move this. Let's move it over here. Let's take it way up high. And we slide it. And we say there's the shorter one. There's the longer one. There's the difference between them. What's that long kind of struggles to see all that? Oh, go back to the bottom. There we go. Kind of weird the way they're doing that. It doesn't work well on the left side. It looks like it'd work better over here. Yeah. It's the same distance on the other side though, because these are mirror images of each other. So if it works over here, that means it works over here. It's just opposite the way I do it. All right. So that's what this is saying when it says a hyperbola is the set of all points where the difference of whose distances from the focal points is constant. The distance is between the difference of those two distances is constant. So each hyperbola has two branches that are not connected, right? Two different, they look like parabolas, but we'll call them branches because they're not necessarily the shape of a parabola. The vertices of a hyperbola are intersected by a line drawn through the two focal points. All right, you're good, Madison. The two focal points. If you connect the two focal points, you'll find the vertices right there on the same line. And then the midpoint of that line is the center. So just like with all the other conic sections, there's two forms of hyperbola. It could be horizontal or it could be vertical. So this is horizontal, right? They point left and right. Could be vertical, could be up and down, like up and down parabolas. So as expected, the standard equation for hyperbola is similar to that of an ellipse, except for a sign change. So here's our standard equation. Let me put this in our notes. Light a little bit, then bleaches out on that side. So for a horizontal transverse axis, which means the hyperbola goes this way. I haven't finished this yet because I want to show you how much it's like the ellipse that we did before. This is almost exactly like last week's. Last week we had x minus h squared over a squared, y minus k squared over b squared equals 1. Except last week it was plus. This time it's minus. That's the only difference. That's the only difference between this week and last week. The ellipse had a plus. This is a minus. And if we have a vertical axis, which means the hyperbola looks like that, and the axis goes up and down, we just trade the y minus k, and the a squared will be underneath here, minus x minus h squared, and it has the b. So the a and b stay in the same place, but we trade places with the top half. See, we just move that. So the y and the h. But this is a vertical. Draw a line between those just to keep our notes straight. Vertical, horizontal. So these are the equations we're going to be playing with this week. So all vertices are a units from the center. Okay, so we need to kind of illustrate this. So I'm going to draw, we'll do a horizontal one. Okay, so if we have the center, well, let's see, the focal points will be on the inside of each side of the hyperbola. The vertices will be on the same line if we have a line that we connect through there lightly. Vertex 1, vertex 2, and then the exact center between those is right there. So this is our center. Vertex is right there.
So question time, answer this we had last week. Let's see.
There's our two vertex and then focal point. And the other focal point over here. So focal points inside, vertices right on the hyperbola and the center. And it said that the vertices are a units from the center. So this distance right here is a. From the center to the vertex is a, which means this over here is also a. All right. And the foci are c units from the center. So the distance to the focal point from here all the way to the center, this is c. From the focal point to the center, which means that leaves us what distance? We haven't found from the focal point to the vertex. C squared equals a squared plus b squared. Oh, this is the Pythagorean theorem. A squared is not necessarily larger than b squared. See, does it give us a distance between? It doesn't say what b is. It does not define b. But we do have a squared plus b squared equals c squared to help us, because we got a and b in the equation. We got a and c in the illustration. So we can use this equation to help find any missing pieces from that. Turn the light on to help a little bit. All right, so that kind of gives us a overall big picture view of how hyperbolas work, knowing the different parts, what their name, the center, the vertex, focal point, another vertex, another focal point. A is how far the center to the vertex is. C is how far the center to the focal point is. And we're going to use the a squared plus b squared equals c squared to help find any missing parts that we have in there. So, all right, let's go back now and see here. If the center is at 0, 0, then you don't have an h and a k, right? It's just x squared over a squared minus y squared over b squared equals 1. That's just making h and k 0. It says, as with parabolas and ellipses, we're frequently asked to write the equation of a conic section and give relevant information. So with an ellipse, we got to find h, k, a, and b. So let's try this problem that they have right here. Find the standard form of the equation of the hyperbola of the foci. All right, so the foci are at -2, 4, and 8, 4. And vertices
When you get older and you get that privilege to vote.
are at 0, 4, and 6, 4. Okay, so let's take a look at, I wrote this down on our paper so we can get started with it. -2, 4, 8, 4, 0, 4, 6, 4. Let's take a look on Desmos, get a visual of that so we have some idea of what direction this is going to be facing. So let's put these 4 points in here. The foci is at -2, 4 and at 8, 4. Okay, these are the focal points. So this is a horizontal transverse axis. So this is the horizontal equation. Our vertices are at 0, 4. We can call that a vertex. We'll label it that way just to help us. And 6, 4.
Has a ridiculous amount of straw. When you think about it, how far does that
And these are foci, so I'll just call them foci. All right. So we know now where the vertices are for both sides. So seeing that this is this shape, horizontal, we're going to need this equation. X minus h squared over a squared minus y minus k squared over b squared equals 1. So let's see what else we need to find out about it. We know that A is the distance from the vertex to the center and C is the focal point to the center. So we need the center. Well, we can look at that real easy and figure out what the center is. What's the center between the two vertex? 1, 2, 3, 4, 5, 6 spaces. So it has to be right here, which would be the point 3, 4, right?
So a big part of
that's the center. Let me write that on our paper. All right, so knowing the center and knowing the vertex, we can get A now, right? Because A is the distance between those. So if we have a center at 3, 4 and a vertex at 0, 4, A must be 3, right? Because that's the difference. 3 minus 0 is 3. So we've got A right there. We need B for our equation, but we don't have that. We have C, though. C is the distance from the center to the focal point. So the focal point is, let's see, the center is at 3, 4. The focal point is at -2, 4. So 3 minus -2. 3 minus -2. C equals 5. 3 minus -2 is 5. So that's the distance of C. So to find B, we can use our equation. So 3 squared plus B squared equals 5 squared. Just substituting A and C into our equation. A squared plus B squared equals C squared. 9 plus B squared equals 25. Subtract 9. B squared equals 16. I don't really have to go any farther because I need B squared. So let's write our answer. y minus, oh, I'm sorry, x minus. I'm doing the wrong one. Horizontal. Subtract the y. Okay, this will be an x minus h. Remember, the center is at hk. X minus 3 squared over a squared. A is 3. 3 squared is 9. Minus y minus k. K is 4 over b squared. B squared is 16 equals 1. Well, let's graph that on our Desmos that we've already filled in the other parts of. So if we said x minus 3 squared divided by 9, that was the first part, minus y minus, and what was the k? 4 squared divided by b squared was 16 equals 1. Hey, perfect. Look, it goes right through the two vertices, which we needed it to do that. So that looks to be correct. Center, focal points, hyperbolas. It is going the right direction. Remember the ellipse, just change that to a plus, and now it's an ellipse. And the focal points are in the wrong place. Since the larger numbers are underneath the 16, that made an ellipse that goes this way. But hyperbolas are subtracting. All right, let's double check our answer. X minus 3 squared over 9 minus y minus 4 squared over 16 equals 1. X minus 3 squared over 9 minus y minus 4 squared over 16 equals 1. Perfect. Okay. Asymptotes. A hyperbola has two asymptotes that intersect at the hyperbola center. So they pass through the vertices of a rectangle, the dimensions 2a by 2b. So let's see if I can find a nice graph of that. Let's see, hyperbola asymptotes. This will show us that, I believe. So looking at this hyperbola right here, it's still loading. I don't know if it's going to load anything. It's okay. It's loading. Look at this hyperbola right here. We've got the blue is the graph of the hyperbola. We've got the center. We have the two vertices. We have the two focal points. You can see the hyperbola, I mean the asymptotes that are the dashed lines. See, those are the lines that as the hyperbola gets bigger and bigger and bigger, as it goes farther and farther and farther, it never touches those asymptotes. It gets closer and closer. You can see as we zoom in, it gets closer and closer and closer, but it never touches those two asymptotes, which is what the definition of an asymptote is, right? It's a line that a graph will approach closer and closer, but never touch. And they intersect at the center. Look, those two asymptotes go right through the center point. So that's how this differs from a parabola. These aren't two parabolas. This is a hyperbola, which is a little different. It has two asymptotes. We don't have the asymptotes with the parabolas. So we can calculate where those are. And it says the dimensions are 2a by 2b. The vertices of a rectangle dimensions 2a by 2b. So looking at what we had right here, 2a, if we graph that, that basically is going from vertex to vertex, right? This is 2a from there to there. That's 2a. And what's 2b? Well, it depends on your hyperbola. On this one, it would be a rectangle. A is 3. Where's A? A is 3. B is actually 4 because b squared is 9. So this would be 2a by 2b. So 6 by 2b would be 8. 6 by 8 rectangle. So if we have the hyperbola drawn, and this is a distance of 6 and 8.
Found that residents of sprawling areas were heavier on
I
average.
think this, I didn't draw that really well. Whew, let me straighten this out a little bit.
But they're not walking. They're not. They're sitting in their car.
It says if you go through the corners of that rectangle, that would actually be the asymptotes. I didn't draw that very well.
Public transportation is key.
But that should be the lines that the hyperbola is approaching and not crossing. It should be, to help you draw that more accurately, drawing that rectangle and tells you where the hyperbola should be approaching. The edges should be approaching. Going through that, this is 2A and this is 2B on the sides. 2A by 2B, rectangle that size. Going through the corners gives you where the asymptotes are. And we can calculate it by, here we go. Let's see. It's the line y equals k plus or minus b divided by a x minus h. So this is the asymptotes for horizontal. So let's calculate what those are, because this was the horizontal. Let's calculate what these are and write those and put them on Desmos and take a look at them. So y equals k. What was our k? K was 4, right? 4 plus or minus, which means we have two different equations. Let's do them one at a time. So we have 4 plus b divided by a. B is 4, a is 3. So 4/3 is the slope. X minus h. H was 3. So one of them is at 4 plus 4/3 x minus 3. And the other one is at 4 minus 4/3 x minus 3. Okay, so let's put those lines onto Desmos and take a look at what we have here. Okay, so we said one hyperbola was y equals 4 plus 4/3. Oh, where's the divided? There it is. 4/3 parentheses x minus. Oh, don't put it on there. Got to put it next to it. X minus 3. Okay, this is one of our asymptotes. And if we look at it, it does go through the center. And look, it gets closer and closer and closer to that line the farther it goes. All right, and then the other one is the exact same equation except with a minus. So I'm just going to copy it, paste it there, and change it to a minus. There's our other one. Those are the asymptotes. The blue and the green lines. So that's where it's different than parabola. Parabola would be turning sharper. It would, these are going farther away from each other. The ends of this goes farther away from each other. Parabolas would be a lot skinnier. So these are not parabolas, but it resembles a parabola when we look at the middle part with the vertex. But we can calculate that. So asymptotes for horizontal. Let's see. We need to write asymptotes. Asymptote vertical y equals k plus or minus a over B. That looks like a 9. Yeah, come on. Yeah, I'm on, Mr. Brock. Make it look like it's an A.
Freedom of movement, you can move around, go play some disc golf, go sledding, go run around, go play football. So these are parks, playgrounds, community gardens.
Okay, horizontal, transverse axis, vertical axis. So these are the equations that we're focused on this week. I think this marker's about to wear out on me. I'm just going to trash that one. All right. Now notice the difference between the two asymptote equations. Notice the difference. This one here at the bottom for the horizontal. Y equals K plus or minus B over A times X minus H. If it's vertical, Y equals K plus or minus, wait, that's the same thing I did here, except A over B. That's the only thing that changed. Still X minus H. The only thing that changes is the B over A or A over B. If it's vertical, it's A over B. If it's horizontal, it's B over A. And it does have that here in the lesson. B over A or A over B is the only difference between those equations. Okay, now, and here's our little chart that they give us. It's parallel, the transverse axis is parallel to the x-axis. That means it's horizontal. Here's how you can find the focal points. Add and subtract C from the center, HK. If it's parallel to the y-axis, you add or subtract C from the K of HK. The vertices, add A and subtract A. There's the equation. There's the asymptote. So this is a nice little chart that puts it all together. Here's all the equations you need. Perfect right here. You have these in your notes. That's all you would need for that. Okay, so let's try this other problem here. Test your skills. Find the coordinates for the foci and vertices. They're going to give us an equation. Find the equations of its asymptotes. So it looks like they want us to do that completing the square thing again. So let's do, let me write this down. Find foci and vertices.
All right. So, question time. This picture on here.
Just remind us what we're looking for. We're looking for the foci and the vertices. So we need to convert this into the standard equation that we're more familiar with working this, which means we have to complete the square. We got to move 4 to the other side. So we've got 16y squared minus 32y minus x squared minus 4x, plus 4x equals 4, because we moved the 4 to the other side. So after moving the 4 to the other side, let's factor out this 16. So this is 16y squared minus 2y. And there's nothing to factor out of that. We'll just leave the x squared plus 4x. Okay. We need to complete the square, which means we need to make this a perfect square trinomial so that it'll end up just y minus some number squared. So if we take this middle number, -2, cut it in half, that's -1. So we know this is going to end up y minus 1, because that's the number we get when we cut it in half. We're trying to figure out y minus 1 squared is what? It's 16 times y squared minus 2y. If we square this, that's a plus 1. So y squared minus 2y plus 1 is the same as y minus 1 squared. And we still have a 16 out front. Minus, oh, this is a minus x squared. Let's pull minus 1 out of there and make that a positive x squared minus 4x. And we need to do the same thing to there. We got to make this where it is a perfect square trinomial. -4 divided by 2 is -2. So this is going to be minus 1 x minus 2 squared. And what's -2 squared? we're going to add a 4. So x minus 2 squared is x squared minus 4x plus 4. But we need to add to this side because we've changed it now. Here, I need to get that out of the way. It doesn't equal 4 anymore because I added these numbers. What did I add? Over here, I added everything inside the parentheses is multiplied by 16. So when I add 1, I added 16 to that side of the equation. Minus 1 times I added 4, so I'm really subtracting 4. So this equals 4 plus 16 minus 4. This equals 16. We're almost there. We just need to simplify this. Let's divide by 16 because this has to equal 1. So divide this by 16, divide this by 16. So 16 by 16, this is just 1. So this is just y minus 1 squared. It's over 1, really. Minus, we've already got the minus we needed. This is over 16, so this is x minus 2 squared over 16 equals 1. Okay, the y is over here. That means this is vertical. This is going to be an up and down. This is a and this is b. That's true for all of them. So a squared equals 1. So a equals 1. B squared equals 16. So b equals 4. And c, 1 plus 16. A squared plus b squared equals c squared. So 17. So c equals the square root of 17. So there's A, there's B, and there's C. It's a number. It's not a nice number. It's 4 point something, but it's a number. And we need the focal points and the vertices. So what is the center? This is y minus k, x minus h. So center is at hk. H is 2. K is 1. There's our center. Our center is at 2, 1. And we already said this goes up and down. Well, that's where this little chart comes in handy if you're using this chart right here. This is parallel to the y-axis. It's up and down. So we got to add the C and the A onto the K part because it's going up and down. The K part. So we said the vertices were A away from the center. So vertices are, they both start with 2 because we're adding to the K, right? So we add A onto the center, to K. K plus 1, K minus 1. So our vertices are at 2, 2, and 2, 0. The foci points, the focal points, 2, comma, 2, comma, and we add C. C is the square root of 17. So this is 1 plus the square root of 17. This is 1 minus the square root of 17. That's where the focal points are. 1 plus the square root of 17, 1 minus the square root of 17. So this should be the answers they're looking for. So let's check our answers and see if we did that right. Okay, the equation. Oh, they get the asymptotes. Center. Okay, the vertices are at 2, 0, and 2, 2. 2, 0, 2, 2. We had that. The distance from the center. So the foci are at 2, 1 minus the square root of 17, and 2, 1 plus the square root of 17. 2, 1 plus the square root of 17, 2, 1 minus the square root of 17. That's great. And it gave the equations for the asymptotes, which it didn't ask us for. Find the coordinates of the vertices and foci. But, oh, afterwards it said find the equation of the asymptotes. Was that our question? Did I miss? Oh, yeah, there it is. Find the equation of the asymptotes. Well, we do that with the vertical k plus a over b x minus h, which a and b are 1 and 4. So it's 1 plus 1/4 x minus 2. Or, oh, and they made it y minus 1. That's weird. They moved the 1 over here. 1/4. It could be 1 minus 1/4, or 4 over 1 this time. 1 over 4 is right. No, a over b. I don't know why they moved the y minus 1 here. Oh, they just gave a different form of it. It's y equals 1 plus or minus 1/4 x minus 2. That would be the two asymptotes. All right, so they're finishing with this table, which gives you all of that. The hyperbolas with centers at HK. There's the way the equations we've been using to find asymptotes, foci, vertices, and the equations. Classifications of conics by general equation. So if you have ax squared plus cy squared plus dx plus ey plus f, if, this is a nice little cheat sheet right here. If it just gives you an equation like this, and you're like, I don't even know what shape that is. If a and c are equal to each other. Oh, I think I'm gonna put this in the notes. This is pretty good. So if we have ax squared plus cy squared plus dx plus ey plus f equals 0. Okay, it says if we have this equation, if a equals c, you have a circle. Interesting. Now I want to prove that to myself. I'm going to go to Desmos. I'm going to get rid of all this stuff.
So if you're using it, Google's not a site.
Okay, a, c, d, e, y, f. A, x squared, y squared, x, y, f. All right. Adding more. Didn't have a slider for f. Oh, add f. Okay. Let's change all these where they're not equal to 1. And let's zoom in because we're zoomed way out right now. All right. Equals 0. So it says if a and c are the same, we should have a circle. Do these need to be bigger numbers? Oh, there it is. The number was just so small it wasn't showing up. Okay. That's interesting. It is a circle. A and C are the same. It's a circle. I got to zoom way in to see it, but it's a circle. If A and C are the same number. If we just move D to a different number and E to a different number, that just changes the size of it. But it is a circle if A and C are the same number. They're both 10. That's an absolute circle. Okay. It says if the parabola, if A times C equals 0, A times C equals 0, where either A equals 0 or C equals 0, but not both. And it's a parabola. Yeah, I wrote that in my notes. If A times C equals 0, that means either A equals 0 or C equals 0, but they can't both equal to 0. Then it's a parabola. So A or C, one or the other, would have to equal 0. So if we go here and we take, let's make C equal 0. Oh, it is a parabola going down. Now let's go back and make it equal to 10, which is circulated, and make A equal 0. Now it's a sideways parabola. Okay, if A or C, one of them is 0, you've got a parabola. All right, how about A times C is greater than 0? Are like signs. They're both positive or both negative. And when you multiply them together, this is greater than 0. And then it says we have what? We have an ellipse. Okay, A and C are the same signs. So that means they'll be greater than 0 when they multiply together. That means neither one of them are 0. So I need to make this like 2 and C is 10. That's fine. That's an ellipse. It said it would be an ellipse if it multiply them together and is greater than 0. If they're both negative, 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 it's an ellipse because multiply them together would be greater than 0. So then the other one it said is if we multiply them together and it's less than 0. Okay, so I like this chart. This saves us a lot of time if they give us one of these problems, like they've done below that. They say classify each of this. What is this? What is this? What is this? Well, we don't have to work it out or do anything. We just look at this chart. 25y squared, 4x squared. We got a y squared and an x squared. Are they the same? That tells us A and C are right there. 25 and negative 4. Well, multiplying those together would be less than 0. So this would be a hyperbola. Here we've got an A is a 9, C is a 4. Multiply those together, it'd be a greater than 0. It'd be an ellipse. This does not have a y squared, so C must be 0. That would be a parabola. I just want to see if that's right there. Hyperbola, parabola, ellipse. Yeah, that's exactly what we calculated there. Let's look at this last one. A times C is less than 0. That means one of these be positive, one of them be negative, and it does make a hyperbola. Look at there. There's the hyperbola. We make A positive and C negative. Just moves it over here. Okay, nice little how to classify what this equation is based on A and C. Really, that's all you have to look at. What's the x squared and the y squared coefficients? That's all you're looking at. The A and the C. All right, let's look at the assignment. Find the vertices and foci. Here's the hyperbola. Gives you A squared and B squared right there. You can figure out what C is. Which are the vertices and foci. Here's an equation. Find the vertices and foci again. You can always graph it in Desmos if that helps you. Go put this in Desmos. This one will help to put in Desmos. Which is the graph of this equation? Well, for one thing, you can look at it and say, is this a horizontal or a vertical? Well, it's got the X on the left side. According to our notes, that would be a horizontal axis. So this is a vertical. This is wrong. This is a vertical. This is wrong. It has to be either C or D, since the X is over here on the A. Find the equation in standard form for the hyperbola that has vertices here and foci here. Which one of these is that? Which one of these has these two? And then here's when you have to do the work. Find the equation in standard form. Here's the vertices, and here's the asymptotes. But the nice thing is the asymptotes give you A and B. You just don't know which it is. Is this B over A or A over B? Well, the vertices help you know that. The vertices will tell you, are these horizontal or are these vertical asymptotes? That'll help you know which one's A, which one's B. And then you can write the equation, because the equation uses A squared and B squared. So all you do is figure out which one of these is A and which one's B. Not bad. All right, we'll leave that. We do have one other thing this week, 603B, the conics collage. So let's look at the instructions. Okay, here is the assessment right here. Find at least 3 examples of conic sections in the real world. You can look at advertising pictures. You can look at architecture, pictures of actual buildings. You can look at nature. So what are conics? Conics are circles, ellipses, parabolas, or hyperbolas. That's what we just looked at. Those are all conics. So you're trying to look in the real world. Where are they using parabolas in advertising? Where are they using circles? Where are they using, 3 examples. Right? And make sure, here's what it says, your collage demonstrates at least 2 of the conic categories. That means you can't use 3 circles. You'd have to have 2 circles and a parabola or a hyperbola, or, So you got to have at least 2 different conics. You can use circles, ellipses, parabolas, or hyperbolas. So put them on a document. Just create a Google document and copy those pictures. So you can do it. You can scan an image from a magazine, take a picture of it. You can make a PowerPoint slide, word processing document, however you want to do that. If you got questions about it, you can make it on a slide if you want. Then, after you get your 3 pictures, and you can put more than 3 pictures, but you have to have at least 3 pictures. Write a brief description about one of them. Oh, look, here's a picture of the Eiffel Tower. Look, the bottom of the Eiffel Tower is a parabola. You can see the parabola there, you know. And then write an equation that represents your conic in its standard form. Oh, look, here's a picture of the London Eye. Oh, here, let's do that. So I'm going to put the London Eye on my collage. Here's a picture of the London Eye. So I'm going to take this picture and put it on there. And then I have to write an equation for it. Yeah, here's all kinds of pictures of the London Eye. So if I use this picture, then I have to write an equation for it. Well, what is the circle equation? It's x squared plus y squared equals radius squared. If I'm using the circle, the right side is equal radius squared. If you put x squared plus y squared equals 1, you're telling me that the London Eye is 1 feet tall or 1 meter tall or whatever you're using. That's a lot taller than 1 foot. So if I'm actually going to use the London Eye and write an x squared plus y squared equation for a circle, I better go look and see how tall is this? What is the radius of the London Eye? What is there? And I can go find that online. This will tell me exactly how tall it is. There's the diameter. It's in meters or feet. It has both. It has meters. It has feet. There's the diameter of the circle. So you can find the radius from there. So you can write an equation for the London Eye or whatever you use. Just make it a realistic. If you don't know, let me emphasize this. If you choose something that you can't find, I can't find the height of this. Just guess a number. As long as it's reasonable. Okay. Well, I couldn't find the height of this Ferris wheel, so I'm going to guess it's 100 feet tall. Okay, I'll settle with that. I'll be happy with that. You'll get full credit. I don't know the height of this Ferris wheel, so I'm going to guess it's 10 feet tall. No, it's not 10 feet tall. Okay, that's not a reasonable guess. If you can't make a reasonable guess, ask somebody. Somebody can help you make a reasonable guess. I can guess, okay, maybe it's 100 feet tall, but no, it's not 10 feet tall. That would fit in this room because this has a 10-foot ceiling. So, all right. Go back and finish this collage, talk real quick. But yeah, write an equation for it. So write a brief description of what one of them is in the picture. Look, you can see in this picture, here's an ellipse or whatever. So here's the equation for the ellipse for that's seen in this picture. Great. So here's what you must include. Your collage. Show me your pictures. A description about one of the pictures. And the standard form equation of whichever one you chose. You can tell me how you found it. How did you find the equation? Oh, I have my notes. This is the equation of a circle. It says at least 100 words to complete sentences. I'm not going to count words. If you're just telling me what the conic is, I'm good with that. Provide the source used for information. If you went and found that the London Eye is 254 feet tall and used Wikipedia, just say, I found the height on Wikipedia. Or I found the height on londoneye.com or whatever website you looked at. Just let you know. And that's it. I'll use here's the rubric if you want to see how it's graded. Let's see, it has at least 3 conics, 2 of which are different. See that's 100% of the points for that. Thoroughly discusses one of the conics. So it talks about which way, hey, look, this is a circle, you know, the circle for equation. Provides the correct equation based on actual or guessed measurements. And it's a pretty good guess. Okay, you get points for that. And you submit it. I'm not, like I said, I don't care if it's 100 words. Complete proper spelling and grammar, and you provide the source where you got the height. If it's a picture used in an advertisement, maybe you just use a ruler. I looked at this advertisement. It was this long. So if you have all of this, 100%. If you only got 2 conics, 75%, you know, so you can see how the rubric. You didn't turn in a collage, 0%. So, but this is the weight. 30% of it comes from this, 20% for here, 30% for here, 20% for here. So, all right. So we have a little grade school project. We're going to make a collage like we did back in grade school, except we had magazines and poster board and glue. Well, I did. I don't know. Maybe you didn't do that in yours. But yeah, collages. You have some fun with it. I've had some people find some very, very, very interesting conics in nature or in architecture. Hey, look, I found this hyperbola used in this building right here. I was like, oh, yeah, that is a hyperbola. Cool. Yeah. So have some fun with that. So we have the conics, the hyperbola assignment, which will ask you the 5 questions, and then you get a collage to put together. And then next week we're testing. So short unit. But that's it. We've covered the whole thing. Any questions on that? And you look at that, didn't understand how the collage works or something. This is an A-Day Friday. So if you need help and you're trying to this, and like, I don't know how to write the equation. I found this conic that I want to use in my collage, but I don't know how to write the equation. Great. Come to class, see me Wednesday or Friday. We'll go over that and show you how to write that equation. So, all right. Anything else? If nothing else, I'll let you guys go get started on this. You got more work to do this week than just 5 questions. So I want to give you time to get started on that for your next class and have a good time. All right, folks. We'll catch you next time. Here if you got questions.